Uh, so we had done 10 questions in the previous class, so this is the 11th. And did you get the right answer to this?
Yeah, I actually got everything right after that.
So 11 to 20 all are correct.
Yeah, for me, everything is correct. There was only totally one mistake in the MCQ.
Okay, which question was that?
That was question 9, which we discussed last time.
Okay, just a second, let me check what was that. Okay, this one. All right, so great. So you got 19 out of 20 correct, right?
Yeah, for the MCQ.
That's wonderful. Okay. Uh, as Mera Khan. Okay, she hasn't. So anyways, let's just start off with the subjective questions, the non-MCQs. For the others, I'll take MCQ later. So okay, this was the first question. So let's check what are your answers to the various questions.
Good afternoon, sir.
Hi Ayush, how are you?
I'm good, sir.
So Ayush, did you attempt all the remaining questions?
Yeah, I finished the last question that I had left.
The question 20th?
No, not in MCQ. I mean, like for paper two, I had a bit of question 4 and 5 left, so I
Okay.
finished.
Okay, so Ayush, what we are doing is we are the 11 to question 11 to question 20. I'll take after the non-MCQ questions. So, is my
Okay.
screen visible to you, Ayush?
Yes, sir.
So it has the first non-MCQ question, the paper 2 question. So just check what are your answers. In the meantime, Somil, tell me your answer to part A.
So I'm not very sure of my answer, but I wrote that the pressure gauge will take some time to change its reading after a change in the pressure has occurred.
It's not exactly. So, okay, so let me explain. So, if you read the question carefully, it has written the temperature has to be constant, right? So, obviously, this is not an ideal case scenario because you have actual gauges. This is an actual experimental setup. So, keeping the temperature constant is difficult. So, what does part A says that after each reduction in the volume, the student waited for some time before measuring the pressure. So the key here is the wait. What will happen when time passes? So basically, the wait is because to allow for the system to reach the thermal equilibrium with the surroundings. So okay, if consider this h, so if I keep this as a variable, either this is increasing or decreasing, then the temperature may also vary. So we consider state 1 as the initial state when, let's say, the h value is let me take any value, let's say 1 meters. Now let's take another state where the h value is, let's say, 1.5 meters. So when I go from 1 to 1.5, the temperature will change because if you see the ideal gas equation, PV is equal to nRT, only the nR is constant, all the other parameters they are variable. So if we wait for some time, let's say at the state 2, okay, consider state 1 as well. So the temperature of the gas which is there inside this column, not gas, this is the air. So the temperature of the air has to be equal to the surrounding temperature, the surroundings in which this experimental setup has been kept. So when we are going from 1 to 2, the temperature will change definitely, but then we will wait till the temperature becomes equal to the temperature of the surroundings. So then basically what is happening is state 1 and in state 2, the temperature of the air is equal to the temperature of the surroundings, and that's what we say, that the temperature has been kept constant. So is this clear, Somal and Ayush, the logic?
Yes, sir.
So okay, let me just
So,
write.
so for the correct answer, can I write that waiting period is to allow the air inside that tube to reach the same temperature as the surroundings?
Yes, correct. So in the marking scheme, they have written this, so I'm writing that down. So the wait time is in order to allow the system to reach thermal equilibrium with the surroundings.
I wrote to maintain a constant temperature.
Ayush, uh, can you
Yeah.
repeat?
I wrote to maintain a constant temperature.
Yes, so that is what basically what is the meaning of what I am writing, to maintain the same temperature.
Okay.
All right, so let's go to the next part, part B. Okay, so you have a graph given, pressure versus 1 by h, and the equation of the line best fit. The equation of the line is given to you, P is equal to A plus B by h. So we have to find the value of B. So Ayush, what is your value of B?
So I got 5.1 into 10 to the power 4.
Okay, great. That is
Because you take B as the gradient, right? So you
yes,
just draw gradient in it and
good.
then rise
Somil,
value.
yes, what's your answer, Somil?
So I got 5 into 10 power 4.
That's fine. So in the exams, anything between 4.5 to 5.5, they have given the mark. So if I, okay, so Somil, how did you get 5 into 10 to the power 4?
So I just use the normal gradient formula, y2 minus y1
Yes,
upon
so
x2
which
minus
2
x1.
points have you considered to find the
I
value?
took 2.5 comma, sorry, I took uh, 5 comma 2.5 and 2 comma 1.
Perfect. So okay, so you have taken this. So 5 comma 2.5 is this, and then 1 2 comma 1, right?
Yeah.
So solving this, your the value of,
I took the points which had most evidently the a good number for the
yes, so
coordinates.
correct, correct. So the value of B is 5 into 10 to the power 4. So Ayush, even your answer is acceptable according to the marking scheme. All right. Okay,
Yeah.
so let's move on to part C. Outline how the results of the experiment are consistent with the ideal gas law at constant temperature. All right, Somil, what is your explanation to this?
So what I wrote was that since the volume is proportional to the change in height when the cross-sectional area is constant,
Mm-hmm.
we can say that P is inversely proportional to 1 by H. Sorry, P is directly proportional to 1 by H because P
Mm-hmm.
is directly proportional to 1 by V. So hence we can say that V is directly proportional to H.
Correct.
Yeah,
Okay,
so I have the same explanation.
great.
And
So
that's where the graph would go through the origin, right? For
yes,
this.
yes. So Somil, we
Yeah.
have to write that point actually. So let me just write it down. So see, the ideal gas equation at constant temperature is like this. So PV is a constant when the temperature is constant. So what we say, that the pressure is inversely proportional to the volume. Now the volume of the air is equal to the area of cross section multiplied by the that height h, which was there in the diagram. So in area of cross section is a constant, whereas the h is a variable. So in place of v, I can put h. So I can write P is inversely proportional to h. So we arrive at this particular expression using the ideal gas equation. Now we will have to check whether this is true according to the graph. So if we observe the graph, so it is a straight line passing through the origin. So if I extend this line, so we'll see that the graph is passing through the origin, and from the graph, if a line is such that it passes through the origin, we can write this P is inversely proportional to h. So it's like this. So if you have x and y axis, and if you have a line passing through the origin, from here we can deduce that y is directly proportional to x, because the equation of this line will be y is equal to mx. So in the case which is given, the y-axis is p and the x-axis is 1 by h, so we write p is inversely proportional to h. So since the line is passing through the origin, we say that p is inversely proportional to the height, and this same thing is what we saw from the ideal gas equation. So it is consistent with the ideal gas law at constant temperature. Is that fine? Saumil, Ayush, both?
Yes, sir.
Yes, sir.
So also for the B part, they have said that we have to find B using an appropriate unit. So
Oh,
what is that unit?
okay.
Is it Pascal meter?
So okay, wait just a second. Ayush, what is your value answer? Sorry.
So for which one?
So part B, we have to find the value of B including a unit. So what was your unit?
Wait, you're asking for part B.
Part B, yes, we actually missed a sub part of B. So just
Oh.
see here, it is written appropriate unit. So what
Yeah.
will be the unit?
So I didn't write the unit.
Okay, no
Actually,
problem.
I just
As of now, can you figure out what is the unit?
yeah, I just checked 1 second.
And Saumil, what is your unit?
I wrote it as Pascal meter.
Yep, that is correct. Good. Are you
Oh yeah, yeah.
figure out?
Yeah, Pascal, PA, Pascal meter.
So how did you get it, Ayush? Pascal meter.
So because we have like the y-axis is in Pascal, but for the x-axis it's 1 by h, which is meter to the power
Yes.
-1.
So
So if you just
Pascals
want to
meter.
take it to h, then it's meter to the power 1. So
Correct. So the value of B was 5 into 10 to the power 4 pascals meter. This will be the unit. Alright, moving on to part D. Ayush, what is your answer to D?
I got 0.026.
0.026. That is correct.
So like
That's correct.
0.03.
Yes.
to round it.
Saumil, did you get the same answer?
Yeah, exact same answer, 0.026 moles.
So 0.026 moles is the answer. So how did you solve this, Ayush?
Yeah, so basically I took the value that we get in D,
Mm-hmm.
and then you multiply it with 1.3 into 10 to the power -3,
Mm-hmm.
and then you divide the whole thing by RT, which is 8.31 into 300.
But how did you get that expression?
Like basically you're supposed to use like PV equals nRT, right?
Mm-hmm.
And in this case you want to find N. So you just equate it according to that, and your R is 8.31. The T is given.
Okay.
1.3 they've given, and 5.1 was what we got in D.
Alright, so let's just check. So we have to find we have to find the number of moles, right? So PV divided by RT is what you need to find. Now the volume can be expressed as area multiplied by the H, the height. Now the pressure multiplied by H, we saw from the previous part B that P into H will be B, isn't it?
Yeah.
Saumil, is this clear? The pressure into height is B,
Yes, sir.
right? So we write this number of moles as BA by RT. Now B value we have already found out. Area of cross section is given to you, and R we know 8.314, and temperature is also given to you. So if you solve for all this, you get 0.026 moles, which both of you have got. Great. Now part E is interesting. So the equation in B is used to predict the pressure at extremely large values of 1 by h. Suggest why this is an unreliable estimate of the pressure. So Saumil, what is your reasoning?
Yeah, so this is one of those sub questions that I had left because I couldn't solve it.
Okay. Ayush, did you write something on this?
No, so even I can get this one.
Okay, what do you think can happen if the value of 1 by h is very high?
So I'm not sure, but is it something to do with like high pressure
Yes.
and then like a
Yes.
small?
So like the pressure will be extremely large and it may be inaccurate because that because it may leak out of that tube or that tube cannot handle so much pressure or something like that.
Now Not necessarily. So let me write the equation. P is equal to A plus B divided by H. So if the value of, say, 1 by H at extremely, so this is very large, which means the value of H will be very small, isn't it?
Yeah.
Now volume is nothing but A into H, where A is your cross-sectional area, which is a constant. We say volume is directly proportional to the height. Now since the height is very small, we will write the volume is also very, very small. Now when we had read the ideal gas law and the kinetic theory model, there were various assumptions which were being I had told you. So what happens is, if the volume is very low, then some of the assumptions of the kinetic theory of gases do not hold. So let me just write that down. At extremely low volumes, some of the assumptions of the kinetic model of gases, they
So
become
like that assumption which states that the distance between molecules is negligible compared to the total volume, I think that's the one
yes,
which gets violated.
correct, good. So that there is one more apart from that. So some of the assumptions of the kinetic model, they become invalid, which means whatever we have reduced from the kinetic model, that becomes invalid. So if we check the ideal gas equation, even this will give you it will give you a answer with some sort of an error, right? So if we find, so what was the question? The equation in B is used to predict the pressure, so we have to suggest why this is an unreliable estimate. So what happens is, if the volume is low, the assumptions of kinetic models are invalid, we cannot use the ideal gas equation, and whatever P we are finding out, this will have some error. Is this clear?
Yeah.
Yeah, sir. So give me a minute.
Okay,
I
so
need to
please
write
write this
this.
down.
Yeah, even I wanna copy it
Yes,
sometime.
yes.
Done, sir.
Okay, Ayush, okay, let me know whenever you finish.
Done. Done.
Okay, great. So let's move on to the next question 2. All right, Ayush, did you attempt this question?
Yes, sir.
So what is your answer to A?
For A, I wrote that the heat is used up in breaking the bonds to turn it to liquid phase.
Okay, good. And so what happens when you give heat energy to the system? It breaks the bonds, right?
Yeah.
All right. So does the, if I ask a sub question, if you
So
potential,
I actually have a bit different answer.
okay, Somil, tell me.
So I wrote that the energy that the solid loses while becoming a liquid is its potential energy, and
Mm-hmm.
it does not lose any of its kinetic energy. And since kinetic energy is directly proportional to temperature,
Mm-hmm.
the Ke since Ke is also a constant, the temperature will also be a constant.
Yes. So actually, the both of you are right, but the real answer is the combination of both your answers. So you have to first start by the whatever heat energy you are giving to the system, that will first break the bonds between the molecules of the substance. First and foremost, that energy goes in breaking the intermolecular forces. So all the attractive forces are broken down. So after that, what happens is the potential energy of the system increases in such a way that the temperature remains constant. Somewhere, like you said, the kinetic energy remains constant. So the total energy of any system is equal to the potential energy plus the kinetic energy. So when the melting is happening, so solid to liquid phase is getting converted, so the kinetic energy remains constant but the potential energy increases. So right, so the actual answer is the combination of both your answers, so please write it down.
Yes.
Yes, sir, done.
Okay, great. Okay, Ayush, let me know whenever you finish. Okay, Somil, what is your answer to B?
So I got it as 4.14 degrees Celsius.
4.1. Okay, it is close, but let's see if you
Yeah,
use the right
don't-
approach. Ayush, what's your answer?
So I got 19.15
No, that
degrees
is
Celsius.
very far away. So Ayush, you have definitely an error. But Somil, let's check if you use the right approach. So tell me your approach, Somil.
So I can just tell you the equation that I have written. Like I actually don't remember what was
Okay.
exactly going on when I was doing this
All
question.
right, no problem. So let me just write down the whole thing, and both of you can then cross check. So we have 3 ice cubes at a temperature of 0 degrees Celsius are dropped into a container of water which is at a temperature of 22 degrees Celsius. The mass of each cube is 25 grams. Mass of the water, that is 330 grams. The ice melts so that the temperature of water decreases. These variable values are given, the specific latent heat and heat capacity. So we have to find the final temperature of the water when all of the ice has melted. Alright, so first of all, this has been clearly given that all of the ice has melted. So first we can figure out how much heat energy will release when all of the ice melts. So let me write that as Q1. So this is the energy released on the melting of ice. So Ayush, can you tell me this value?
So for which one? For Q1?
Yes, so what is the total energy released when all 3 blocks of ice they are melted?
So I wrote it as 3.3 into 10 to the power 5 whole into 3.
Okay, so see, the value of Q is given by mass into the latent heat of fusion. The M here is the total mass of the ice cubes. Since there are 3 ice cubes, we will write 3 multiplied by 25 grams. So that will be the total mass. And LF is the latent heat of fusion of ice, which is given to you as 3.3 into 10 to the power 5. So if you solve for this, you will get 24750 joules. So please check your approaches and see if you got this value.
So I understood.
What was the mistake?
I wrote the wrong formula itself. I derived the formula that 3 mc delta T equals ml.
Okay, no, so that formula is used when the temperature is getting changed. So in this
Yeah.
case, ice is getting melted, temperature remains constant, and the formula we use is just ml. Samir, did
Yeah.
you get this value 24750?
Yeah, so this value I got.
All right. So now what is happening is all the ice has melted. Now, so as of now, the entire system is just water because all of the ice has melted. Initially the water was at 22 degrees Celsius. Now we have to find out what will be the temperature, what will be the final temperature. So two things will be happening. So consider the water which was present initially, whose mass was 330 grams. So the 330 grams water which was present initially, its temperature was 22 degrees Celsius. It falls to some value T, which is what we need to find. Now the ice,
So I think I understood my mistake.
and what was it?
So for the mass of the water that I had taken, I had only taken it as 0.33 kilograms. I didn't add the
Ice.
mass of the 3 ice cubes.
Okay, so yes, that is an error. So anyways, let me tell you the approach. So you have ice as well, and what was the total mass of that? 75 grams. So that 75 gram ice which got converted into 75 grams water, Now that water initially was at a temperature of 0 degrees Celsius. Now Ayush, tell me, is this clear to you? Why is this 0?
I didn't like have, is that 75 grams?
Yes, so this 75 grams is the total mass of all the ice cubes, which is 3 into 25.
Yeah, okay.
So tell me, is this clear when I say that this 75 gram ice, the temperature, initial temperature of this was 0 degrees Celsius.
Yeah,
So basically what happens is 75 grams ice converts into 75 grams water, and the temperature is 0 degrees Celsius. Now finally this temperature also goes to this value, the equilibrium temperature T. So the water initially, which was at 22, it becomes T degrees Celsius, and also the water which is coming from the ice, that changes from 0 to T. Please tell me, is this clear?
so could you explain once more?
Okay. So see, initially you had just water which was at 22 degrees Celsius and the mass was 330 grams, right?
Yeah,
And initially you had ice, you had 3 ice cubes, so 3 into 25, which will give 75 grams ice, right?
yeah,
So when 75 gram ice melts, you get 75 grams water, right?
yeah, yeah.
Now this water goes into the system and it gets added into the water which was initially present. Now 330 grams at 22 degrees Celsius, but the water which is coming from the ice, that is 75 grams, but its temperature will be 0 degrees Celsius, isn't it?
Yeah,
Now we
because
have
it's
to
like,
find the equilibrium temperature. So the 22 will drop to a value T, and this 0 degrees Celsius will increase to T.
okay.
Ayush, please
Yeah,
pay attention. Is this clear?
yeah, sir, got it now.
Right. So okay, so okay, let me summarize the whole thing together. So you have the 75 grams ice, that converts to 75 grams water. This is at 0 degrees Celsius. Now at equilibrium, this 75 grams water, at equilibrium, let's say the temperature is T degrees Celsius, and on the other hand you had water which was already present in the container, 330 grams. Its initial temperature was 22 degrees Celsius, and when the system reaches equilibrium, the temperature has to be constant. So this water then converts into water which is again 330 grams, but the temperature will be T degrees Celsius. So this entire thing is your thermal equilibrium state. Is this clear to both of you?
Yes, sir.
Right. So initially we saw what was the total energy released on ice melting, that was 24750 joules. Now Ayush, if I ask you, let's say from this to this, when the water coming from the ice, its temperature increases from 0 to T, what do you think? Do you need the heat energy, or the heat energy will be released?
So can you, I didn't understand your question.
Okay, just a sec.
So,
Yes, Amar.
so just for confirmation, I solved it after correcting my mistake. Is the answer 5.4?
No, Somal, the answer is 3.4. So you have to
So what
check.
I did was I 24,750 that I got correctly.
Mhm.
But for the other thing, what I did was for 330 grams, the temperature decreases from 22 to a temperature T.
Mhm.
And for the 75 grams of ice cube, the temperature increases from 0 to a temperature T.
Yes, correct.
Yeah, that's what I did. But how
Okay, so
like I'm
let's check one by one. So let's check it out. So Ayush, clearing your doubt. So initially the ice had melted. So okay, this is not energy released. This will be energy needed. So Ayush, when ice melts, you will require energy to melt it, isn't it? Ayush?
Yes, sir.
Right. Similarly, if I want to raise the temperature of water from 0 to a higher value, I will again need some energy, isn't it?
Yeah.
And similarly, if I consider water, which was initially at 22, the temperature drops, then what do you think? This energy is getting released or putting into the system?
So if it's dropping, then that means the energy is getting released, right?
Yes, this energy is getting released. So
Yeah.
basically, this energy will be responsible for the melting of the ice as well as the increase in the temperature. So let me,
So basically, that energy will be used for the gain from 0 degrees to 3 degrees.
yes. So okay, let me just summarize. Initially, you had 75 grams ice at 0 degrees Celsius. That got converted into 75 grams water at 0 degrees Celsius, and this value was Q1, which you found out from that formula M into L, 24750 joules, isn't it?
Yeah.
Now, what is happening is this Q3 will be equal to the sum of these two, Q1 and Q2. So tell me, is this clear? What have we done?
Yeah, it's clear.
Samuel, is this clear? Q3 is equal to Q1 plus Q2.
I am not very sure what are Q3, Q1, and Q2.
Okay, so wait, let me repeat the whole thing. So initially,
No, there's no need to repeat. Like I'm just like I'm like Q3. Is it the energy released by the 330 grams of water?
yes, so water 330 grams, the temperature drops from 22 to T degrees Celsius, the energy will be released. So this is the released energy. And Q1 and Q2, both of them are absorbed energies. See, Q1 is the heat which completely melts the ice into water, and then Q2 is the heat which increases the melted ice into water at T degrees Celsius. To raise the temperature from 0 to T, the heat energy required will be Q2.
Okay, so like my equation was correct, just that there was not an error but an understanding error in the plus and minus sign. So
Okay,
now I'm getting 3.4.
that is the correct answer.
So sir, just to be sure,
Mhm.
24750, that is the only, sorry, not that, 24750, and the energy gained by the 75 grams of water
Mhm.
is on one side, and the energy lost by 22 degrees Celsius of 330 grams of water is on one side.
Absolutely right.
Okay,
Correct.
now I got it.
Now, Ayush, did you get it till this point so that I can proceed?
Yes, sir.
So on one side you have the released energy, on the other hand it is the absorbed energy, Q1 and Q2. Q1 you have already found out using M into L formula, and Q2 is the heat energy required to increase the temperature of water from 0 to T degrees Celsius. So we will use the formula Ms delta T for this particular Q2. Now mass of the water in this case is 75 grams. The specific heat, it is given to you in the question. What is that value? It is 4.2 into 10 to the power 3. That is the specific heat. And in place of temperature difference, Ayush, what will you place?
So you will put 22 minus 0, right? In this case.
No. So the we are considering just Q2, and Q2 is this from this point to this point. So the temperature is increasing from 0 to T degrees Celsius. So what is
Achha,
delta T?
3 minus 0.
Yes, so it is just T. So delta T will be just T. So this is your Q2 value. Now the value of Q1 is already you have found out. Q2 is this. Now let's check what is Q3. Now we have to first understand what is happening in Q3. So water, this is the original water which was 330 grams. Its temperature is getting changed from 22 to T. So what do you think is delta T, Ayush?
So it will be T minus 22.
Yes, although it is T minus 22, but you have to do a small modification. So if I write down the formula first, ms into delta T, this is the energy released. So the mass of the water is 330 grams. Now this is the water which was already present in the container. Specific heat will be 4.8 into 10 to the power 3, and delta T. So this is the key. Although the temperature is getting decreased, so 22, so it feels like your delta T is this, T minus 22, but T is definitely less than 22, isn't it, Ayush?
Yeah.
So this will be a negative value. So
Yeah.
to avoid this, what we write delta T as this, 22 minus T. So this is the left hand side, and on the right hand side you will have ml, the value which was 24750, and then we write this entire thing, which is 75 grams multiplied by 4.2 into 10 to the power 3 into capital T. Ayush, still you understand till this point?
Yeah.
Can you solve for this and find the value of temperature?
Yeah, 1 second. So is it 3.4?
Yes, that is correct. So 3.4 degrees Celsius.
Okay.
Now Samil, since you have understood the whole thing, could you please repeat the whole thing for me? What have we done for this question?
Okay, sir. So we had 330 grams of water and 3 ice cubes were put into it at 0 degrees, and the water was at 22 degrees. So once we put the ice in that, the ice cubes will absorb energy from the water, so the temperature of the water will drop. But since they have mentioned that the ice has completely melted, so after melting they will also turn into water, and their temperature will also rise.
Correct.
So then we generate an equation. So the mass into the specific latent heat of fusion, that is the energy that will be absorbed by the ice, and then the mass of the ice cubes into specific heat of water into T minus 0 will be the energy absorbed by the water which was initially ice, and then 0.33 into specific heat of water into 22 minus T is the energy that is released by the water, which is 330 grams of water.
Correct.
So we just form an equation and solve for T.
Correct. Now, Ayush, this was a little tricky question. So even if you have doubts understanding this, you can go through the whole thing again, and you can please ask the doubts later. Is that fine?
Yeah. Okay.
So, by the way, did you understand?
Yeah.
Okay.
I got it.
But I would want you to go through it again.
Yes.
Next question. Question 3.